Good day, everybody. We have a problem today that deals with equality of two different positional number system bases. Now, I'm looking for a real life rational number, not one with the denominator of 1. So this q minus z just means all the rational numbers, not including the integers. For example, let's say 7 over 1, okay, is not a member of Q, Q the rational numbers slash Z, okay? But 7 over 3 would be, right? Okay, so again, we're just looking for a real life fractional number here. All right. Now, so again, we have these two bases here. This is base B, and this is the conventional base 10. This is often omitted, but just for the sake of clarity, I'm going to include it this time. We're looking for a B that satisfies this statement, okay? And then we want to evaluate O.24, a decimal value with our new base, okay? So you're given in advance there is such a Q, which is such a B, which is a lot of people aren't used to working with fractional bases and positional number systems. But let's get busy. So here we get this is equal to 261. Okay, and then if you subtract the 261 from both sides, you would end up with what, 3b squared plus 4b and then when you subtract 261 from 1, you get minus 260. So this would be minus 260 right here equals to 0. Now the way the problem's set up, one would anticipate a factorization here. You could use the quadratic formula if you wanted. But it does factor into 3b minus 26 linear factor. (3b minus 26), and I believe, let's see here, if you multiply this out, I think you get b plus 10. Now again, we were looking for a solution. A fractional solution. So it's pretty clear right here that this is the one that's going to get the job done. So you would have this right here would intimate that b is equal to 26 over 3. By inspection, right? You don't have to be formal here. B is equal to 26 over 3. Again, folks, that means we have a fractional base that satisfies the original equation. Notice that b equals negative 10 is the solution. Also, it's kind of interesting. You can have negative bases that work just fine. There's some debate about whether you should allow fractional bases because of it screws up the ordering, I think, of the real numbers, sort of. I'm not sure about all of that. But in any event, I just worked it out for you right here. This is the number we were supposed to evaluate, right? 0.24 with our b, which we know is 26 over 3 right now. Okay, and again, I did most of the arithmetic for you right here. This would be equal, if you want to simplify it, I think you get 4 times 48, and then 26 is 2 times 13, so you would have 4 times 13 squared right here, right, folks? I hope I'm doing the arithmetic correctly. Right, 4 times 48 is the 192. The 4's cancel here. And let's see here, 48 over 13 squared would be 48 over 169. Now, something I don't understand, which confused me quite a bit actually. So this is the answer we're looking for. Is when I tried b equals negative 10, we didn't get the same value. So there's something up with that. I don't know if it has to do, I don't really understand it. It seemed like that b equals negative 10 should also work here, but it doesn't, or at least I don't think it does. I may have made a mistake in my calculations. But anyway, we did answer the question that was to be asked: is what does this decimal? This is a very odd situation, right? We have a decimal raised with a fractional base going on here, so it's normal in the sense the math doesn't care, but just I think most of the time in the at least in the U.S. high schools and colleges, I don't think they deal with fractional bases very much. Probably a good reason for that somewhere along the line. But we've completed the problem. Hope you enjoyed.